Hi there, and welcome back to the Complete C Sharp Masterclass. In this module, we'll have a look at how practically dependency injection works, why it's really useful, and we'll have a look at the three different life cycles and how we can use it. So, first thing, if you wish to follow along, we're currently on the master branch, so you have to go check out the relevant branch that we'll be working on. So let's just give this a second to load up and then we'll check out that branch. So the first thing is you're gonna have to say git fetch and then and git checkout 0 to hero dot di dot questions. So this will go and then we'll say git and git pull. So what this is gonna do is it's gonna go and fetch the branch and then it's going to check out the branch that we need to work on, and then it's going to pull all the latest changes into our local repository. So let's go into the code now, and then we'll reload this because there's new changes that I've picked up. It's preparing the solution for us, and then we'll dive straight into it. So here we have a couple of examples. We have a program, we have a service runner, we have three different items that we'll go through in terms of the code. It will be the same for all of them. The only difference will be the way that we register each of them. So let's dive into the service runner and let's first start with transient. So we'll just run the application first and then we'll see what it does under the hood. Okay, so here we get the module and then we can simply just select the cycle of it. We'll simply go and say, okay, please give us transient, and then we'll go and see three items logged here. We'll go into the detail of what this is actually doing underneath, and we'll go through each of the life cycles. So we'll start off with transient. So let's have a look here. We have a service runner. The service runner basically runs the application on an infinite loop until we've said no, we don't want to we don't want to try this anymore, right? Here we have three different life cycles: singleton, transient, and scoped. And what this does is it simply goes and it gets the life cycle, which goes and reads in some input from the user, and then we get what life cycle it is dependent on what the user has entered, and then it simply just does what it needs to do. So let's start off with transient and see what the difference is. So here we have three different services. So the first one is we have a logger that handles logging, and then we have a payment service that makes payments. We have a data service that goes and adds in data, and then we have a customer service that handles customer information, and then we have an authentication to log in. We have authorization to authorize certain functionality, and we have an identity service that uses both of them. And then we simply build a service provider up to facilitate the actions. Now, this is very important because this is really where we add the mapping. Now, if we just hover over this here, we can go and see this adds the transient service type specified by iLogger with the implementation in file logger in the specified item. Now, this is important to understand because what this is actually saying is, hey, here's an interface. This is the concrete implementation of that interface. Now, the important thing to remember about dependency injection is the order in which the items are injected matters. So let's simply just start off by looking at how this looks, and then we'll get back to this point later onwards. Let's go and see the logger. So here we have a logger that simply is able to log a message. Very simple interface. And this just logs a message. We don't know where it's going to log it to. It just knows I just need to log it. And if you recall the interface section or the module on this, interfaces simply say, hey, I'm a contract. And this contract is between me and a implementer. The implementer will say, hey, this is how you implement this specific service. So here we have a file logger. So this file logger implements the logging that simply puts that into a file and stores it. Obviously, this is just a marked out implementation of this for the sake of the presentation. So moving on, let's see how this is now being used within the payment service. So here what we simply have is a mock of what a payment service would look like. So here we go and say, hey, we inject the logger and we create a private field for this. and then we simply just log this to where it needs to go. So this service is simply injected in and it's just assumed that it works. We don't care what implementation it is. It could be an implementation of a database logger, it could be an implementation of a file, it could be just to the console. It doesn't really matter. And that's where the power of dependency injection comes in. It simply just knows it's a dependency and the dependency is resolved by the container. So, yeah, at a high level, that's really what it simply does. And then here's another example. So, let's have a look at this. So, here we have a data access item that simply just stores data somewhere. It doesn't really matter where it does, as long as we have an implementation of this. We'll go to the implementation, and here we just have a faker that could be saving data to the database, maybe with Entity Framework. We could use Dapper, we could use NoSQL. It doesn't really matter. The focus here is like we're able to create a database access that implements the iDatabase access interface, and it simply just saves an item. In this instance, it's really just a mock, so it's just printing out to the console, hey, we've saved this data for this specific item. And then this will simply just go and use it in the logging to save it to the database, but it just fakes it in the background. So then we have a customer service, and the customer service then goes and says, hey, just add a new customer with this name. And this is supposed to go into the database and just save that customer name. In this case, we're just adding a new string, and that string will just print that item onto the console. But again, we see the same thing, right? We have this the iDatabase access that's injected, and it doesn't necessarily care what this is. This could be like an actual database access. It could be whatever item that's implemented by this interface, and it would simply just work the same. So even if I had to swap this out for an actual database or wherever else it would save that data to, this underlying customer service would not have to change. It would simply just continue working as long as we've registered the new implementation of this database access. So it's a really powerful technique, especially when building out a new project or you're attempting to just mock something out and get a quick solution out. Dependency injection is the best for that. It also allows us to make more reusable code because we can simply then just go inject the service wherever else it would be needed. So if we needed, let's say, another service that does something that needs to be able to save data, we could simply just inject it in there. And we see this again and again with something like, let's say, like a repository pattern, where we would need to save data. We can just inject that repository pattern into every service that needs it, and it would simply handle saving the data. Very, very powerful. It allows us to create really awesome code. Now, in a moment, we'll get back to why the order of this matters. So you can see here the payment service, for example, depends on the logger. So this is where the importance of order happens. If we had to put this above the logger, this would fail because the dependency service depends on this module. It depends on the logger. So if the logger isn't provided before the payment service is provided, it will fail. And the same thing goes for the customer service. If the customer service was registered before the iDatabase access, the database access would fail because it wouldn't know what to do with that service. It's like there's a dependency that's not resolved. So if you do run into that issues, it's most likely because the order in which you added your items is not correct. So yeah, we have the same thing. So let's jump into like the identity service. This is a little bit more of a interesting implementation of how we could go about implementing authentication and authorization. So here we have a service that goes I authentication, I authorization, and it simply knows, hey, I need to be able to log in and provide access to this resource. We'll see if the user can access this resource. These are the two services that need to be registered in order for this to work. If these services are not registered, this simply won't work because these services need to be registered prior in order for the identity service to work. So let's just see how this looks. So here's the two methods that implemented here, login and access resource. So let's go and have a look at how the authentication and authorization looks behind. So here we just have like a static list of users that has username and password. And again, this is just for the concept itself. not necessarily for the actual implementation. So here we go in and we'll just check in the dictionary, is there an actual item for this? Now, this is useful because then the authentication service could just be swapped out for another implementation of this that actually uses a database. We don't actually have to care about how this implementation works as long as the authenticate is provided. It can do any kind of implementation. So it's a very useful and a powerful way to go about building a system. We just mock it out and then eventually when we need to, we implement the actual item piece by piece. So yeah, the same thing goes with the I authorization. Here we have a simple response that is returned when it's authorized. So we have some user roles here. So this user item has this role, this user has this role, and then these are the roles that you need in order for you to access the specific system. So you need to be an admin in order for you to access HR. You have to be a normal user in order for you to access the accounting module. And then we have a simple authorization here that goes and says, hey, does this user exist? If this user doesn't exist, we simply say, hey, this user doesn't exist. You're attempting to access something that's invalid. Then once that user does exist, we know we can just go and check, hey, give me the role for this user. So this user will go and it'll say, oh, okay, cool. This user has this role or this role. And then we store that role into a variable and we simply go and say, hey, in the roles resources, if this is an admin and the resource they're trying to access is there, then it's correct. If not, then well, you can't access it. So we simply go in here and we say, hey, return what this response is that has access to resource. In this case, if they do have access to it, this will return true, and then it'll set the message and say access has been granted for the resource you're attempting to do, or it will just say unauthorized. And then this item will just simply go in here and say, hey, this is actually just invalid, if that makes sense. So at a high level, that's really the difference between them. So if we had to run this now, let's just have a look at this. Yeah. So this is what it does in the background. So again, this is where we'll go and store it. User access has been granted for user one. And then, yeah, that's simply it. So the registering of those services simply just work out of the box, which is a very cool approach because then all we need to know about is as long as the dependencies that we need has been registered, it will simply just work. Again, this is supposed to be transient. So yeah, let's just change this to transient. So yeah, this needs to be transient here in order for it to access the rest of the items. But yeah, that's at a high level how this would work. So the only important thing to remember is we need to always make sure that the order matters. And the order is always defined by the using service. So this order wouldn't matter even if we swap these two around because they're both used by the identity service. So if you look here, these are the dependencies. So this doesn't matter in what order it is, unless these would take in respective items themselves. So if in the constructor there were additional items, we would need to register those first before we can register this. So that's just something to bear in mind. But yeah, that's it from the transient services. Next up, we'll have a look at scoped and we'll see the slight differences. So yeah, I hope you guys have enjoyed the module. And yeah, that's pretty much it for this one. I'll see you guys in the next module.